Okay, so today we are going to discuss about superposition principle. Okay, of light. Basically, what we want to do, as we have said in the class before, that there are two sources of light, S1 and S2, and we will assume that, and there is a point P, and light ray is coming from these two sources and reaching this point. So these are the light rays that are coming. Okay. Now this light ray is basically, light is an electromagnetic wave. So I'm drawing the electric field which is oscillating perpendicular to the ray. And there is of course also a magnetic field which I am not drawing. So these two light rays are coming, and as a result electric field from source 1 and there is electric field from source 2, both are present at the point P. So at P I can write EP is equals to E1 plus E2. So there are few things that I have said in the class in the previous lecture, which is we will going to assume that E1 is A1 sine omega t, E into E1 cap, this is the unit vector, E2 is A2 sine omega t plus some initial phase, say delta naught, into E2 cap, with the assumption that E1 cap is equal to E2 cap. So with that assumptions, we have already found out that E total will be equals to, at P, will be equals to E1 plus E2, sorry, A1 plus A2 plus 2A1 A2 into cos delta. In that delta, we have the information. What is delta? Delta is equals to K into x2 minus x1 plus delta naught. Well, what is x2 and x1? So this length is x1, this length is x2, and from there I have got this. There are various things that are interesting here. One is we haven't given the vector sign. Two is the assumption that we have made E1 hat equals to E2 hat. Third is usually the electric field, because it's a wave, should have a form which is equals to A sine kx minus omega t. So why we are not taking the kx, but this has been discussed before, so I am not going into that. Anyway, with these assumptions I am going to get, let me write this as the total amplitude AP. So I am going to, and I have also used the fact that the intensity is proportional to A square. With this assumption, we have already derived I is equals to I1 plus I2 plus 2 root over I1 I2 into cos delta. Fine. Now what are these? So this is the intensity at a point P. This is the intensity that is coming from source 1. This is the intensity from source 2. And this is the resultant intensity, final intensity. Fine. Now, so this we have done in the class. Now we are going to take this expression and we are going to see what are the interesting things about that. So I am going to write this again. Ip equals to I1 plus I2 plus 2 root over I1 I2 into cos delta. Now if cos delta is equals to 1, I can write this as Ip is I1 plus I2 plus 2 root over I1 I2, or I can write this as root over I1 plus root over I2 whole square. Okay, this is called, so why I'm going to, okay, fine. So what else? If cos delta is minus 1, then similarly I can get Ip equals to I1 plus I2 minus 2 root over I1 I2, which will give me root over I1 minus root over I2 whole square. Fine. Now what does that mean? That cos delta sometimes is plus 1, sometimes is minus 1. As I said, in this delta you have what? K into x2 minus x1 plus the delta naught. So depending on the P, if I change P, so if I change P, that means if I go to a different point, the x2 and x1 will be different. So delta will be different. So I can choose various values of delta because the various P is going to, we are going to take various position of the P. Okay. So for the case of some P for which cos delta is equals to 1, I am going to get the maximum intensity. For the case cos delta equals to minus 1, I am going to get minimum intensity. Okay, which means now cos delta equals to 1 is called interfere. So this process is called, this superposition of principle is called interference, and this cos delta equals to 1 is called the constructive interference. So for constructive interference, we get cos delta equals to plus 1, and the resultant Ip will be equals to root over I1 plus root over I2 whole square. And if I1 equals to I2, that is contribution from two sources are same, is equals to I naught. So IP I am going to get 2 I naught whole square, which is 4 I naught. Okay, fine. So let us try to understand. First of all, what do I mean by that? So what is the case when cos delta equals to 1? So for cos delta equals to 1, delta has to be equals to either 0 or 2 pi or 4 pi, etc., etc. So let me write this as concisely as 2n into pi. Now with this, now I know that the delta equals to k into x2 minus x1 plus delta naught. What was delta naught? Delta naught was the initial phase difference between the two sources. Okay, fine. And what was this? This is the phase difference that is arising because of the difference in the path length or because of path difference. So this is the phase difference due to path difference. Suppose delta naught equals to 0. So delta is equals to k into x2 minus x1. K is the wave number, so I'm going to write that as 2 pi by lambda into del x2 minus x1 I'm going to write as delta x. So delta, which is basically the difference in phase, is equals to 2 pi by lambda into delta x, right? Okay, so I will stop here. Then in the next